All right, so last time we were taking a look at these conversions, and we actually did some conversions where we took numbers in another base. In particular, these are the two that we did, 3 and 4. Okay, so last time we were on this particular slide, and we had what we worked on last time is we worked on taking numbers from another base into our base, and the operation that we used to do that, as you take a look at on 3 and 4, was a multiplication procedure, and then we had added the facts together. What we're going to work on this lesson is we're going to take the same idea, but we're going to work it in the other direction. Now instead what we want to do is we want to start with a number in our number system and turn it into a number in a different base system. Now, in order to do that, we actually have to know what the base values are in the other system. Now, since this says base 4, that means we need to take a look at the powers of 4. So the first power of 4 is 4 to the 0, which is 1. And the second power of 4 is 4 to the 1, which is 4. So I have a 1 and a 4. And then once I have the 1 and the 4, I can simply multiply by 4 to get the next one. So 4 times 4, 4 squared is 16. 16 times 4 is 64. 64 times 4 is 256. Then 256 times 4 is 1024. 1024 times 4 is 4096. And then 4096 times 4 is 16,384. And that value I know for sure I'm done because that one's too big. It's too big to divide the 11,028 by that value. So we know that the largest value that will go into 11,000 is the 4096. So we're going to do 4096, and we're going to divide the 11,028 into the 4096. If we divide that, it goes in evenly twice, and then if you take the 4096 times the 2, you get 8192. And you subtract that from 11,028 to get 2836. And then what we're going to do is we're going to use these powers of 4 that we had written to the side, and we're going to just go in order all the way down the list. So 4096 is where I started, 1024 is next. 1024 clearly goes into this twice, and 2 times 1024 is 2048. So we're going to take 2836 and subtract 2048 for a total of 788. And then the next value down the list is 256. 256 will divide into this evenly 3 times, or fully 3 times. 3 times 256 is 768, which is very friendly because the subtraction is of course very easy, and I just have the number 20. Now, as odd as it sort of feels to do it, the next number on the list is 64, and I realize 64 doesn't go into 20. That's okay. That just means it goes in 0 times. So we're going to write the number 0 over here, and 0 times 64, of course, is 0, so I still have 20 left over. Now, if you're working on your paper, you can continue this process. I'm just out of space, so I'm going to move over here. And then after the 64, the next smallest value is a 16, so we'll divide by 16. Of course, 16 goes into 20 one time. 1 times 16 is 16. If we subtract, we have 4. The next power down the list actually happens to be 4. Obviously, 4 goes into 4 one time. 4 times 1 is 4, and a remainder of 0. But please don't stop here. You're not done when you get a 0. You're done when you divide by 1. So dividing by 1, of course, there's nothing left to divide it out. So we have this next number is 0. But if you forget or if you stop too soon, you're not going to have all of the digits you need, and you need that last 0. It is part of your solution. So your solution I've highlighted here is in green. You've got 2, 2, 3, 0, 1, 1, 0, and you must write down next to it the base that you're in. This is base 4. All right, so let's try another one. Just for kicks, we created one that's got 99,999 and it's going into base 9. And of course, the humorous thing, if you will, if there's humor to be involved in this, is the fact that this is in base 9, and there, of course, aren't any 9s in base 9. But I draw your attention to it because I don't want you to think that that just means somehow those 9s turn into 0s or 1s or something else, because that's not what happens. We still have to go through the exact same process as we did on problem number 5. So, since this is base 9, we need powers of 9. So the smallest is always 1, and the next largest is the base that we're in, so it's base 9. After that, I can actually look at either thinking about powers of 9 or multiplying the result that I've got before by 9. So 9 times 9, or 9 squared, is 81. After 81, if I multiply by 9, I get 729. And if I multiply that by 9, I get 6561. Multiplying that by 9 gives me 59,049. And I can actually stop there because when I look at this, I see, oh, I've got 99,999. This number's 59,049. It's almost the same value already. It clearly, if I multiply 59,000 by 9, I'm going to be way too large. So I'm going to take that 59,049 and divide it into 99,999. It goes in one time, so then we will subtract 59,049. And 99,999 minus 59,049 is 40,950. All right, so we're just going to again go down the list. The next number to divide by is 6561. So if I divide 40,950 by 6561, it goes in 6 times. 6 times 6561 is 39,366, which I will subtract from the 40,950 to give me a result of 1584. The next power of 9 down from that is 729. 729 will go into 1584 2 times. 2 times 729 is 1458. And if you subtract that from 1584, you get 126. Next power down is an 81. So 126 obviously will have 81 going into it one time. Subtract 81. My result is 45. Next power down is 9. 45 divided by 9 is 5. And that actually zeroes it out. But again, don't get too quick to say you're done. You're actually not done. You're not done until you divide by 1. And 1 will clearly go into 0 times. But you still need it. It's part of your solution. There are 0 1s in this problem. So your solution is 162,150 base 9. Now, a real quick thing that you should look over as you're doing this, and you should keep in mind as you're doing this, is that all these values that I just highlighted in green, both on this problem and on the last problem, they actually need to be values that exist in the base you're working in. So I'm working in base 9 on this problem number 6. If I had gotten any number bigger than 8, I would know I made an error somewhere and I've got to go back and fix it. So if this division gives you 12, or if this division even were to give you 9 in this particular case, it'd be too big. All of my numbers need to be between 0 and 8 because I'm working in base 9. The same thing was true back here on problem number 5 for base 4. All of my values have to be 0, 1, 2, or 3. No other bigger values. So if you divide and you get, say, 13 or something like this, in base 4 there is no 13. That doesn't make sense. And so you know you have an error. Either you wrote the powers of your base down incorrectly, maybe you've got one missing, or maybe when you did your division you just made a calculator error. But that's a point where you need to stop and say, wait a minute, what did I do wrong? And fix it. All right, let's take a look at problem number 7. Problem number 7 is actually taking a number in one base and turning it into another base, but if you'll notice, neither of those bases are base 10, or neither of them say decimal form either way. So what we're going to do this, however, is that we're going to start in the first base that we're given, in this case base 5. And I want to eventually turn it into base 7, but I'm going to do an intermediate step and I'm going to turn it into base 10. So we're going to go from base 5 to base 10 and then into base 7. All right, so as a quick reminder, anytime we go from a non-decimal base, like a base 5 or 7 or 12 or whatever, into our base 10, that is a multiplication operation. And anytime we go from base 10 into base 7, that is a division operation. So this is a two-step problem. It doesn't tell you that. You have to recognize that that's what's necessary in order to do this problem. Now, I've got a 4 and I've got a 3, and this is in base 5. So this is 5 to the 0 and 5 to the 1. All right, so 5 to the 1 is the same as 5. So this is 4 times 5 to the 1, or 4 times 5, plus 3 times 5 to the 0, and 5 to the 0 is 1, so it's just 3 times 1. I end up getting 20 plus 3, or 23. Now you can leave that written as 23. It's perfectly fine. If you want to get in the habit of writing subscripts, or you just want to remind yourself that you're not done, this is 23 base 10, because we are currently in base 10 with our value. Now we're going to take that number in base 10 and we're going to turn it into base 7. So we need to know powers of 7. So the first power of 7 is 1, and the next one would be 7. After that, we would multiply 7 times 7, or 7 squared, which is 49. 49 is too large because my number is only 23. So I'm actually going to have a pretty quick and dirty little division algorithm over here. I'm going to start with the 23, and I'm going to divide by the biggest power of 7 that goes into that, which is 7. 7 goes into 23 3 times. 3 times 7 is 21, with a remainder of 2. And then 1 goes into 2 2 times. 1 times 2 is 2. Get my 0 at the end. My solution then is right over here, the 3 and the 2. This would be 3, 2, and again, you're in base 7, so you must write base 7. Now, just as a second, I would like for you to take a look and think about or compare something that's going on here. The original number I had up here, right? Let me do it this way. And then this number right here in base 10, and then the comparable number in base 7. I want you to notice that the smaller the base, which the smallest one of these bases is base 5, the larger the value next to it. Right? So base 5 has a 4, 3 next to it. Smallest base, largest value. Likewise, the biggest base, base 10, has the value 2, 3 next to it, 23, and that looks like the smallest of those three values. Again, one of those check steps you can look at and say, does it make sense? And if you don't have that kind of a correspondence going on, you've made an error and you need to go back to take a look at what that might be. All right, let's do another one. Very same directions, but we're moving from base 2 into base 8. Now, numbers in base 2 look a little funny since they're all 1s and 0s. They end up looking quite long, but the value doesn't usually end up being very much in terms of our base 10 values. So I've actually got the numbers 1, 1, 0, 1, 0, 1, 1, 1, 1, and then 0, 1. Now just like on the last slide, and I'll write it up here again too, I'm going from base 2 into base 10 and then into base 8. Also again, to go from base 2 into base 10 is multiplication, and then to go from base 10 into base 8, that's division. Sorry, that's as high as I can write my D. Maybe I can move it up a little bit higher. Let's see. Well, I could if I had, yeah, I don't think we're going to work on that. All right, so just know that's division. All right, so the numbers that I've written out correspond to the original problem. These are all powers of 2, so let's figure out which ones we have here. It always starts with 2 to the 0 on the right, and then it increases by powers of 2, and increasing my exponent, so 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th, 2 to the 8th, 2 to the 9th, and 2 to the 10th. And we're going to multiply, but the cool thing about multiplying in base 2 is that since you're multiplying by 1 or 0, you either get the value you're working with, right? 1 times 2 to the 10th is just 2 to the 10th. Or you get 0, right? Because like 0 times 2 to the 8th, that's just 0. So everything I get is actually either a power of 2 or nothing. So this is 2 to the 10th, plus 2 to the 9th, plus 0, plus 2 to the 7th, plus 0, plus 2 to the 5th, plus 2 to the 4th, 2 cubed, 2 squared, 0, and 2 to the 0, which is 1. So let's do some powers of 10. I'm sorry, powers of 2. 2 to the 10th is 1024. 2 to the 9th is 512. Of course, I've got that 0 there. 2 to the 7th is 128. Got yourself another 0. 2 to the 5th is 32. 2 to the 4th is 16. 2 to the 3rd is 8. 2 squared is 4. Have myself another 0, and then 2 to the 0 is 1. So we're going to add 1024 plus 512 plus 128 plus 32 plus 16 plus 8 plus 4 plus 1 for a grand total of 1725. And that's great, but it's 1725 in base 10, so I'm not done. I need to be into base 8. So to move myself into base 8, I actually need to use, excuse me, the division algorithm that we learned before, that scaffolding. So I need some powers of 8. So let me change color just because I'm going to run out of space here and I don't want it to get confusing. Base 8 is going to have powers of 8. We're going to start with 1 and 8, of course. And then 8 times 8 is 64. And if we do 64 times 8, I get 512. 512 times 8 is 4096, and I am too large because my number is only 1725. So I will start. I don't have to do quite as much division as I have on some of the others. And I'm going to divide 512 into 1725. This will go in 3 times. 3 times 512 is 1536. So 1725 minus 1536 is 189. 189 will then be divided by the next power down from the 512 and the 8s, which would be 64. This will go in also 3 times. 3 times 64 is 190. Oh, I'm sorry. It would only go in twice, I guess. Let me pause on that for a second and fix that. All right, that's better. It goes in twice. 64 times 9, or times 2, is 128. All right, so 189 minus 128 gives me a 61 result. 61 then gets divided by the next power of 8, which happens now to be 8. 8 will go into 61 exactly 7 times. 7 times 8 is 56. And then 61 minus 56 is 5. 5 divided by 1 is 5. I've got my remainder of 0, and my solution, as we were looking at before, is over here on the right-hand side of this. My solution is 3275, base 8. So let's pause and take a look at this from the perspective we talked about on the previous slide. The biggest base, which is base 10, is the smallest number. It's 1725. The smallest base, which is base 2, is the biggest number. It's 110101111101. And then 8, of course, is in between there. It's the in-between base. It's the in-between number. All right, we have one last question. We're going to take a look at putting these numbers in order from least to greatest. Now, it's this kind of like when you think about comparing or putting numbers in order from least to greatest for fractions. It's very difficult to compare fractions of, say, 2/3 and 7/15. How do I decide which one's bigger? Well, the easiest way to handle a problem like that in the fractions case is to get common denominators. Here, same idea. I need to get common bases. They all need to be in the same base to be able to be compared. And the easiest thing to do, since they're all in different bases, is to turn them into a base 10, because then I can actually look at them to compare. So I'm going to start with the 43 first. I'll just label these A, B, C. And we'll start with letter A, which is 43 base 7. Now, we've talked about how to do this. This is 7 to the 0 and 7 to the 1. So I have 4 times 7 to the 1, which is just 4 times 7, plus 3 times 7 to the 0, and 7 to the 0 is just 1. So I end up with 28 plus 3, or a total of 31. And again, you can leave this as 31. If you would like, you can write this as base 10. Just follow what my math lab suggests that you need to do when you do this. I'm not sure if they'll accept either of those solutions, but I certainly will if you do it on a test or on your homework. All right, part B then. Part B looks like I've got 1, 3, and 2. So actually the number looks bigger than the number 4, 3, base 7, but it's a smaller base, base 4, so it's difficult to make the comparison. All right, so we've got base 4, so this is 4 to the 0, 4 to the 1, and 4 squared. So I have 1 times 4 squared. 4 squared, of course, is 16, plus 3 times 4 to the 1, or 3 times 4, which would end up being 12, plus 2 times 4 to the 0, and since 4 to the 0 is 1, that ends up being 2. So I have 16 plus 12 plus 2, and that actually results in a value of 30 in base 10. So it's actually smaller than part A, which looked larger, which looked smaller than part B when we first started it because they had different bases, which made it difficult to compare. All right, so C, we're going to take a look at A2. And this is in base 11, so we've got powers of 11, 11 to the 0 and 11 to the 1. Now what I really need is I need A times 11 to the 1, and I need 2 times 11 to the 0. But if you'll remember, this A right here is actually equal to the value of 10. So what I really have is I have 10 times 11, or I have 110. And then 11 to the 0, this value is actually the number 1, so then I have 2 times 1. And 2 times 1 is, of course, 2, so this total is actually 112 base 10. There we go. So that's definitely the biggest. Now the directions say that we want them in order from least to greatest, right? Least to greatest. So the least one is clearly this 30 base 10. But we're going to do the values we were given. The 30 base 10 is actually the equivalent value of the 1, 3, 2 base 4. So we're going to write it first. The next biggest value is the 4, 3. So this is 4, 3 base 5. And then the largest value is the 112 base 10, which was A2 base 11. So that is what my solution ends up being for this particular problem.